Okay, so Dr. Amit Kumar Singh, thanks a lot for your time, sir, for this interaction.
Thank you.
Okay, and Dr. Amit, I welcome you on YourPedia Education. And today our interaction is related to the recent project which was displayed in the first ever research and development fair which was conducted in IIT Delhi on 14th and 15th of October. Professor Amit, you are doing marvelous work in the field of 5G communication, and one of your projects was displayed in IIT Delhi. The name of the project is Innovation in Millimeter Wave 5G Communication. So I would request you to first please brief all my viewers here about this particular project. Okay, so Dr. Amit, I would request you to tell all my viewers about the recent project, one of your projects which was displayed in IIT Delhi in R&D fair. The name is Innovation in Millimeter Wave 5G Communication. So I request you to please tell the viewers about this project.
Okay, so first of all, thank you all the viewers for having a look on this particular platform. So in the recent R&D fair, which was organized by Ministry of Education and in particular the IIT Council, where from our lab side, the lab which we call it as Meta Antenna Lab, we have actually displayed 3 projects. All these 3 projects were consolidated to a single name, which we gave as Innovations in the Field of Millimeter Wave Antenna Designs for 5G Communications. So in particular, just for all the viewers' sakes, just I want to say, like very recently people may have heard about Prime Minister launched the 5G for general public uses. By the launch of the same, when Prime Minister launched the same in Indian Mobile Congress, which happened in Delhi very recently, that started already in some of our cities, including Delhi and Varanasi and some other cities. So the innovation which we did is we started for this long back with the mission and vision to fulfill the 5G, and not only 5G, I will say the next generation communication requirements of the humanity, which is of huge impact. So in case of this particular 5G, as per the standards, frequencies are divided into several bands as per the standardization is concerned. So the one is the sub-6 gigahertz band, which is launched very recently for 3.5 gigahertz band 5G application. The other bands are again the millimeter wave bands, which we call it as, that lies near about 28 gigahertz, 24 gigahertz, 38 gigahertz band, again going further 70 gigahertz and even more further about. So depending on the choice of, depending on the uses in the geography, the planning and the architecture of these particular frequencies are governed. So our research which we did is that was in millimeter wave antenna design. So these antennas are specialized antennas to give very highly directed beams and with very small size that we designed at 28 gigahertz application and 38 gigahertz application. So the size of the antenna, just you can think of twice the size of 1 rupees coin or 2 rupees coin maximum. So that size of the antenna, and that is more than sufficient to give you very, very high directivity and high gain. In simply saying, by using these technologies, we can detect movement of small ants at a distance of 200 meters, 300 meters or so. And this is something called the beauty of this 5G at millimeter wave band frequencies. And as far as users are concerned, they are going to be much more user-friendly. At the same time, very, very less cost. That means reliable to the pocket of the customers, as far as Indian base is concerned.
Okay, great. So, Dr. Amit, very nicely and lucid way you have explained the entire project. In fact, my next couple of interaction points and questions are related to these technologies only, which you mentioned. But before that, my next question is related to you, Dr. Amit. You have received your PhD degree from Center of Applied Research in Electronics, which we call CARE. That is IIT Delhi. That is a very wonderful department, and you have got that in 2018. That means you are a very recent PhD graduate. how was your PhD journey, and what tips will you give to the budding PhD aspirants? And I'm asking you specifically because I'm also alumni of IIT Delhi. I've done long back doctorate from IIT Delhi, and I'm of the opinion that you get tremendous opportunities the moment you graduate from the such institutes if you invest your years properly, and you get opportunities in industries and academia and so many opportunities. But students are not much aware. So even if they want, they by temperament wise, they want to go for these kind of super specialized courses. What what deviate them from pursuing such courses is a lack of awareness of the opportunities. So since you represent a very good department in IT Delhi, I will request you to tell students, all of my viewers here, about your own journey since you have recently traveled there.
So first of all, thank you for putting such excellent question. For a PhD research scholar or the one who is doing PhD, the question itself is very amazing question. How is your PhD journey? Mm-hmm. So in particular, PhD is not just a degree for me, in my opinion. Mm-hmm. It's complete story of the life. It's complete learning for the life. Mm-hmm. That means in a PhD, it's not just that you will be sitting on your workstation or you will be doing something. You will have to face n number of challenges, yes, especially in particular to the environment where IITs and our lab like CARE, microwave labs and similar kind of labs at our IIT Patna also are concerned. Mm-hmm. So being in that particular labs have lots of expectations, at the same time lots of different challenges in particular life, personal life. Same thing was with me also. So I joined my PhD in 2014 July, and starting from that July, had numerous discussion on the current trend of the technology, not in India. We were thinking with our supervisors to the global level. That is the kind of impactful technology at that point of time was the emerging 5G to worldwide. So we started working on that particular technology by using the metamaterials, and from 2014 onwards. So actually PhD journey itself, like research journey itself, takes some time to grow up. That once we cross that particular threshold, then our outputs looks like, okay, some prototype is developed, some devices are developed, some algorithms, some theoretical understandings that are developed. So that took for me again about 1.5 years to reach until that level. So then after we started producing lots of very important instruments and important devices, in particular to the microwave side, RF side, and again to the millimeter wave side. And they were very excellent works which we did that time. And in particular, I will say like PhD is a journey which you enjoy at your own. At your own means if you will to enjoy, you will. If you don't will to enjoy, for sure you will not. So it's on you. It's on the one who is doing the research. Because research cannot be imposed forcefully. It comes from the heart, it comes from your mind. And hence the fruitful research goes on. So that was the learning which I got during my PhD journey, and exactly the same thing we do with our students. Like until unless you don't have a problem definition from your own mind side, your own heart side, then until that you cannot learn far. Here I will quote a very specialized word by Professor Kalam. He used to say, no, like the one which you dream, that you cannot dream when you are sleeping.
Yeah.
That dream you will have to be in awakened condition.
Yeah.
And the same thing is valid for this PhD journey. So that was very interesting journey for me. So this was one domain of the life, that was the research for this particular PhD. Other than this research, communities and institutions like IITs, they offer you lots of variety of works to do for. Especially like lots of various cultural activities, spiritual activities, physical activities. You can take part of that also. It's not like joining a PhD degree, just doing research. It's not at all. You have complete 3 to 4 years, again, depending on what type of research you are doing, to enjoy the campus life. And that is, again, one of the beautiful part of complete duration of our life, in my opinion.
Wonderfully said, Dr. Amit. And that is what should be inspirational things for students to listen. It is going to be difficult. I mean, it is going to be difficult, but as you said, depends how you take it. Because when you are want to get super specialized, there will be ups, there will be downs. My professor used to say it is like a sine graph, sometime up, sometime down, sometime up, and you need to maintain your rhythm. That is how it is. Dr. Amit, IIT Patna is not the first institute which he joined as faculty. In fact, in March 2020, and maybe that is a COVID time it was. So entire COVID duration, you were assistant professor in IIT Jammu, which was established in 2016, new IIT again, and that was your, I think, first your teaching stint in IIT system. I want to ask you your experience with IIT Jammu also, and how IIT Jammu is doing.
Thank you. So, in my academic career, IIT Jammu was the first institution where I joined as assistant professor after returning back from Korea. When I joined IIT Jammu, just after a week, Prime Minister imposed lockdown.
Yeah.
So actually, when I was in Korea, I had heard lots of about this COVID-19 virus and so and so. Actually, those side it already started long back ago. So when I say joined this IIT Jammu, just after a week, complete lockdown was imposed. And during that particular COVID time, it gave me a very wonderful opportunity, not just to work on our specialized technology, but to work on the kind of technology which is relevant to the society. For example, during that COVID time, we worked on the designing of the compact ventilators. We worked on designing of the face shield, the masks, the UV sterilization units, and all other devices. They were having not to do with high frequencies. They were not having to do with the kind of anything with the communications. But even after getting back to these topics, after so long time in your study and in your career, even we were not quite sure when it was given to us, like you people have to design portable ventilator. We were not sure like we will be able to design or not. We took it as a challenge and we started developing that. And in a confined time, we developed the type of prototypes which are not just equal to the standards, but it performed quite well above those standards also. So that COVID time in IIT Jammu gave me this particular opportunity to emphasize and to develop my other skills also technically. At the same time, my involvement was more towards defense and space related works, even from previously before joining IIT Jammu as well. So being in Jammu, it gave me a particular base in Jammu itself, where we performed lots of R&Ds and lots of development in that sectors as well. So the stay at IIT Jammu was very, very nice as per being my first organization to join in my academic career. And as of now also, when I returned back to Patna IIT, before that we developed a wonderful tinkering lab at IIT Patna in association with other professors there. And that is again, they are performing very excellent at this point of time. One of the standard art of lab at this point of time. So the IIT Jammu is growing very excellently.
So you truly converted adversity into opportunity for you during the COVID years. That is wonderful, Dr. Amit. Now I'm coming to your field of specialization, Dr. Amit, and that is 5G communication. We hear a lot about 5G communication. First, we heard about 4G communication, and it's a buzzword in the field of electronics and communication. It is a buzzword. I want you to explain us in a very clear term, very simple terms, sir. What is the meaning of 5G communication? What are the benefits of 5G communication, and what are the main features of 5G?
Okay. So I will say in a generic manner, like when you communicate means the transmitter and the receiver communicates. Okay. So when communication happens, then transmitter and receiver both have expectations to transmit as much they can, depending on requirement. So this as much have lots of data. Lots of data means if you want to transmit some file, some folder, some data in terms of video, some data in terms of real-time video, and again different data. So depending on the requirement, by time, depending on the requirement, we moved towards high data requirement. So to fulfill the desire of the user moving towards high data requirement, at the same time, minimization of the time. That is, ultimately, user started going towards high data rate. Secondly, at the same time, the second aspect was the quality of the services, either in terms of the voice or in terms of the transmission, audio, video, or any such things in real time. So all these things emphasize to move the technology towards the next generation. And the next generation, which we thought of, which the technologists thought of, that was the 5G. And when the technology moved towards 5G, that was again to fulfill the need of the humanity. That is one of the major one, that was the communication. When I am saying the humanity, this doesn't mean only the human beings. This also includes all the devices which are with human beings. That means my gadgets, my mobile phones, laptops, my each and everything in the houses. And in the coming generation, this fifth generation, each and everything is with this mobile networks or this data rates. So everywhere we have huge requirement of the data rate, and that is something called this fifth generation 5G services.
Wonderful. So very simply explained, Dr. Amit. And what we understand 5G communication, what a common layman understanding is, like our speed of internet will increase. So my next interaction point is related to the speed only of internet. So when can we enjoy, Dr. Amit, the internet speed of 10 gigabits per second, which we expect, and at what cost end users like me can enjoy that particular speed? So when can we get that, and what will be the cost part of that?
Okay. So as far as the users, the consumers, as a normal people, we are concerned, the 5G are being imposed or being established in some of the cities by the authorities, like the Department of Telecom, the TRAI, and other regulatory authorities in some of the cities as of now. And they already started going towards high data rate, about several Gbps. Now, when the same network seems to be expanded to throughout the country or to at our level at the user end, it will need some time. As per the TRAI standards and Department of Telecom standards, it is going to take again 1 year probably, because the same thing was announced by Prime Minister itself in the Mobile Congress, that maybe probably by 2023 March or maybe 2023 December, probably the end user is going to have the experience of the 5G at that moment. And this is going to provide very huge change in terms of the infrastructure. In terms of infrastructure means the communication infrastructure, at the same time the mobile operators. Means at each and every poles, each and every height, each and every structure can be used like a BTS. It's not now the one which is the fixed tower which a user is going to have for, they were using for 3G, 2G, or even for 4G. Now, depending on the requirement of the data rate, like if let's say if we are in rural areas, those rural areas people, we may not need very high data rate. And when I am saying very high data rate means 100 gigabytes, I am saying. And so the rural areas have their own particular requirements. Urban areas have their own particular requirements. Similarly, the standardized technical areas or some commercial areas, they have their own standard requirements. So depending on all the requirements of the user, the kind of sectorizations will be done. And depending on their requirements, the services can be provided. And this is the kind of flexibility which 5G has.
Okay, wonderfully explained, Dr. Amit. And you mentioned about the infrastructure part of providing this 5G communication. My next interaction point was related to that only. So It is claimed that 5G communication will not require high power cell towers to radiate signal over longer distances. So, to what extent that statement is true, Dr. Amit?
Actually, this statement is partially correct. When I'm saying partially correct, means as I said previously, 5G will have different bands, different frequency ranges, depending on the requirement of the users.
Okay.
Let's say for rural areas, but if we have to provide the wider coverage, if that is that is the majority and that is the priority, then depending on that, we will select that particular frequency band. So when we have to provide the higher coverage, for that purpose, we will be using for sure the high power radiators. And that is also not going to impact the human beings. Why? Because all those are standardized and well tested in the experimental labs, perfectly verified. Then only this technology goes to the market after standardization.
Okay.
And when it comes to the higher data rate side, maybe as a subscriber, as a customer, I may be also worried if I am getting high data rate, whether it is costing too much or it is having some harmful effect or some kind of power hungry devices, something like that. But actually it is not going to be. That is the kind of misconceptions some of the users have. The same was previously with those developed countries also, where it was already where it is already functioning. But the scenario is not going to be that. The one where we have the lower ranges of the coverage, at the same time, if we want to provide high data rate, the power requirements are going to be again very less, because higher frequencies need not to travel the larger distances. Their requirement goes in terms of the data rate. So for that purposes, higher frequencies will be concerned. So there we don't need to transmit high power. Okay. So it again goes to how much bitrate you want, how much download speed, how much upload speed, how much internet speed, how much data rate you want. Depending on that, the power requirements are concerned. So they are perfectly related to each other.
Wonderful. Dr. Amit, we also hear about some new buzzwords in technology like IoTs, Internet of Things and all. And I believe that, because of emergence of communication, good communication like 5G communication, there will be new opportunities in the world of Internet also, like IoTs and new technologies. Should youngsters start conceiving startup ideas around industrial IoT, keeping the emergence of 5G in mind? When 5G comes, these are the new opportunities which will pop up in these fields, something like that. So what is your take on that?
Yeah, so I have the opinion, like in the coming days or in the coming generation, it's going to be each and every accessories, each and every component, either they are the living or not, they are going to have their own intelligence, although they will be artificially developed, but they will have some kind of intelligence. So we are going to be with intelligent device in the next generation. The coming one, that is the 6G type of thing. So all those devices have to do some kind of communication in between, together, or with the human beings also. So for all these purposes, what is needed is the wireless communication, the high data rate again, the bandwidth requirement again. So as of now, as a single user, if I am using the network, I may use, let's say, several Mbps. Okay. But at the same time, in my household, I am using 10 or hundreds of gadgets at a time. Even if one gadget is needing several Mbps, I have hundreds of gadgets. So we will be needing Gbps of data for just for 1 hour, just for maybe some minutes. So these are the kind of huge requirement of data is going to be in the coming generation, the coming future. That's why the term which we call it as Internet of Everything. And so everything is going to be connected through these data in the coming generation, and hence, for sure, the Internet of Things converted to Internet of Everything should be the more emphasized topic to the youngsters to learn for. And I will not just say to the youngsters, I will say even to the school childs, they can also go for those types of things. And these technologies are really very, very interesting, and they can go for lots of enormous developments in the same field.
Wonderfully explained, Dr. Amit. So from Internet of Things to Internet of Everything with the help of 5G, that explanation is really beautiful. Dr. Amit, in your project, I found a word millimeter wave. And I want you to explain us what is the meaning of millimeter wave and what is the significance of this in 5G communication.
So during my previous discussions also, when I said like 5G have different bands of operation, depending on speed, depending on the requirement, depending on the data. So one of them is something I told like millimeter wave band, like 28 gigahertz, 24 gigahertz. During my previous discussion, I said. So exactly the millimeter wave band is the wave which have the wavelength in millimeters.
Okay.
Simple definition. Like if a wave propagates, like we technologists see, like if waves are propagating, they have a particular wavelength to propagate for some minute, for some second, and accordingly the frequencies are defined. So frequency have its own standard definition, accordingly the wavelength, and hence the one which have millimeter wavelengths, we call those frequencies at millimeter waves. So in general, we say from 30 gigahertz to 300 gigahertz range of frequencies, we call it as in millimeters. As far as user aspect is concerned, again, these are going to have data rates which is very high. At the same time, the compactness of the devices, they are going to be very compact, very easy to handle. They are going to be just a kind of in the coming generation, maybe our laptops are just going to be converted into the our mobile phones having flapping structures, complete CPU converted into a simple mobile phone. These are the kind of data rates and the story towards the compactness in terms of the millimeter waves and going towards the terahertz. That is the 6G.
Wonderful. So when we say millimeter wave, Dr. Amit, the radio waves in millimeter wave band have high atmospheric attenuation, and they are absorbed by gases in the atmosphere also. So is it not a big drawback for communication engineers, those who are working in millimeter wave band?
See, the atmospheric absorption is not too much for millimeters. The main hurdle towards millimeter waves are the blockage. Blockage in terms of some kind of, let's say, if we have the wall, we have the doors, we have the glasses, or it can be any object. So those kind of penetration capability, these millimeter waves don't have. Why? Because the frequencies are going towards higher side, so it cannot penetrate in particular. It will die in between after some wavelengths. So to mitigate this particular one, the technologies are like from the same radiator, how we can provide coverage to the one who is in that blockage area in particular. And the kind of technology which we develop is which we call it as beamforming. And by using those beamforming approaches, even we can provide coverage to that particular area where we don't have the particular radiations. So for that particular, we provide the beamforming approach or the massive MIMO approach or the kind of specialized beam to a particularly defined user without going toward that blockage, without going toward that hurdle. Okay. So in general, for sure, it have the problem of blockage, but there are technologies to mitigate that.
Dr. Amit, you also mentioned about your stay in South Korea and your postdoctoral fellowship there before you joined as faculty. So my next point is related to that only. Postdoctorate research you have done from Korea Advanced Institute of Science and Technology. And interestingly, if we see, South Korea is the country which adopted 5G on a large scale. And in April 2019 itself, they adopted that on large scale. And that time you happened to be in the, South Korea itself. So what was the impact of 5G on South Korea? You must have observed that, and we want to know it from you.
So luckily, when I started my journey to South Korea, there we had seen lots of technological changes. In particular, since 2019 April, they already implemented this particular 5G for their users. So just you can think of the same 5G we are trying to implement today. That means at least these countries are about 5 years ahead from us in terms of thinking. And so the technology is also there about 3 to 5 years ahead. That means the technologies which they were using that time, now we are going to use those technologies. Just for example, like the kind of the video conferencing which we are doing as of now, or the kind of live telecast or live kind of coverage which we are doing of now, that too in a limited data rate. We had seen these technologies there having a very excellent kind of quality with excellent data rate and without any kind of hindrance, without any kind of data problem. This was the one. Second was the automation. The kind of automation which we have seen in South Korea that time itself. About 2019 itself, like autonomous car I have seen to be developed in those labs that time itself. The kind of drones were communicating in millimeter waves and those very high data rate kind of communication by using drones. They were having those kind of technology that time. And luckily, I was also involved to that particular lab where we go towards the development of the 5G technologies that time itself in South Korea. And the same we are extending to our infrastructure here to again go beyond that technology in our labs here.
Okay, so we hope and we expect the similar kind of developments and the changes, Dr. Amit, back home also in India also. Now, Dr. Amit, I am going to discuss with you another very latest research domain in the field of material science, and that is metamaterials. We talk about metamaterials, and I want you to tell us how metamaterials are able to manipulate the electromagnetic waves.
So firstly, I will tell you like what exactly metamaterials are. Like metamaterials are not normal materials, not the general materials. They are artificially engineered materials. And for these materials, what we do is we go for the engineering of the particular atomic level and subatomic level engineering, so that we can transform the characteristic of the atoms itself. Only the difference is those atoms we call here as unit cells. So we do the kind of changes with this particular unit cells and the kind of characteristics of material. If we are towards electrical engineering side and its characteristic, we call it as permittivity, permeability, and refractive index. Similarly, mechanical people may call some kind of different characteristics like stress, strain, or whatever other kind of characteristic they have. So our job towards these metamaterials are like, can we develop the kind of material which have negative refractive index? Negative refractive index means, just for example, if I am saying, let's say if I am just sitting like this posture and I want to see what is happening on my backside, that I cannot see normally because the tendency of the light will propagate from the transmitter to the receiver. Again, after reflection, I can see what is happening. But what if I want to see what is happening on my backside? That is also possible physically. If we design these types of material which have exactly the reverse characteristic which the medium as of now have. The medium, that is the air medium, and the one which we are interacting, they have the positive one, and hence propagation is the forward. Similarly, if the medium which we design is the negative one, then the propagation will be the backward one, and hence we can see all the kind of activities happening to the backside also. So these are the kind of excellent characteristics which we used to develop with our materials by designing these unit cells as a specialized unit cell, and hence they have this particular special characteristic. And because of that only, with less cost, but because of the engineering involved, we have this specialized, very highly directive and very cost-effective antenna systems or other systems which we have developed at our lab.
Wonderful. And Dr. Amit, you also mentioned about the size of the antenna, which is reduced largely. So what is this metamaterial antenna, and how is it able to behave as if it were much larger than its actual size?
So as I said, like these materials have different characteristics. And these characteristics are being governed by the approach by which user can design that. Let's say, like if for me, if the target is to reduce the electrical length of the propagation, and if my target is to increase the length of the propagation, and if my target is to miniaturize the size of the radiators, that also this metamaterial structures can do, and that they can do very excellently. because they have the kind of trapping capability, they have the kind of diffraction capability towards negative, positive. Again, depending on our requirement, they have enormous other capability. Means saying in a single word, by using these metastructures, we can go towards miniaturization. In our lab, we have gone till miniaturizations of about 80%. That means, let's say, if for some particular design, if I need 1 meter height of antenna, that we can go miniaturization by 80%. 80% means we can make them by 20 centimeter, which was previously of 1 meter. So these are the kind of technologies, again, which we can develop by using these metastructures.
Dr. Amit, I was going through your research work and publications, and there I found repeated use of one term, which is meta-surface lens. So I request you to explain us again, what do you understand by meta-surface lens, and also tell us meta-surface lens for gain enhancement that you have designed.
Thank you. So just now I said, like, metamaterials have some important characteristics and important property. So the one was the miniaturization, which we just now discussed. The others are the convergence of the beam, the convergence of the electromagnetic bands. So these lenses, which we call it as the metamaterial lenses, are behaving exactly same like which we have the concave convex lens for optics, for opticals. So for electromagnetic waves, the approach was, can we design those types of lenses? For example, if we have the concave lens, we used to have in our childhood, we used to have an experiment, like by using concave lenses, how to burn those particular papers or some grass hops or something like that. That was just because those concave lenses can convert the sunlight, and because of that, the total intensity sunlight increases and it starts burning. So exactly the same approach we thought of can be applied here also, because ultimately they are waves. Sunlight is also wave. So if sunlight can be converted by using these types of concave or convex lenses or divers, so same thing we can do with electromagnetic waves also. Having the same approach, which was already existing in nature, we try to apply it with our own devices, and we develop those concave and convex lenses. Again, we played with those metamaterial unit cells, metamaterial atoms, redesigned those structures, and after redesigning these structures, we gave the name as a lens, because it was having the nature of convergence. And hence, having, when I said convergence, means the beam, the gain, which was very less previously, now because of using that particular lens under some particular different condition, the same gain increased enormously because of this convergence. And hence the applications also started moving towards lots of different applications with these lenses.
Okay. Dr. Amit, there is something which is called MIMO antenna, if I'm pronouncing it properly, MIMO antenna. So what is the importance of this antenna in 5G communication?
So MIMO, it simply we call it as multiple input, multiple output. And that's why this word MIMO is. So we say, like, when we started our discussion, we said, like, the next generation communication means we have to serve n number of users at a time with n number of different requirements. That ultimately goes to multiple number of inputs at a time for a single device. At the same time, they have to work for multiple number devices, multiple outputs. And hence, this technology which we use for our this 5G or even the beyond one which will be used, that is something which we call it as MIMO, that is multiple inputs and multiple outputs. So there we can use on a single system more than one antenna system, where one can transmit, one can receive, or at the same time both can be done by the same system itself, and hence the wording MIMO.
Okay. Okay, so Dr. Amit, how will you explain to the general public about the innovation, about your innovations in millimeter wave 5G communication? Please, if you can explain in simple words, so that my viewers who are mostly undergraduate engineers, they also understand about these kind of innovative things.
Okay. So in particular, to moving towards these types of technologies, these are like the objective going to be how to have, if you want to talk in terms of the data rate, how to get higher data rate. just the saying higher data rate doesn't mean only a single line. To develop the complete technology, complete system, a complete setup, complete algorithm is needed, which the researchers works towards that. And then after it comes to the general public in terms of, just for example, like those who must be maybe using sometimes earlier like 2G services, the GSM. So the internet through those GSMs and now the internet through 4G services like LTE, there have huge differences in terms of various differences. Similarly, the next generation will expect quite a lot more. Now the scenario is in our country, most of the youths, they have their smartphones nowadays, which we did not have at our time in our schools. So the scenario completely changed. In the coming generations, it may be like every user may have more than one smartphone or one smart device. So as a researcher or as a student, the innovative ideas should be there. Like since the data requirements are increasing, so how to fulfill that particular data requirement? And that's why the kind of domain is moving towards how to provide the user higher bandwidth, at the same time higher efficiency, at the same time the accuracy. And all these things should be also cost effective. So having all these things in mind, how user can, how researcher can, how engineer can develop these types of technology. This is the main thematic idea which any student, any of the citizen, any younger generation may have moving towards this particular one. And for sure, technology is not going to stop at just the millimeter wave. There is long beyond this millimeter wave to go far.
Dr. Amit, you are presently in IIT Patna and earlier you were in IIT Jammu. The kind of research domain you are working in, they are latest domains, like we talked about metamaterials, meta lenses, MIMO antenna, and 5G communication. So, are the lab facilities developed in these new IITs? What kind of lab infrastructure is required? And when you are working in these kind of technologies, then I presume that latest lab facilities must also be required. So how far have you attained that particular level in your institute to develop those lab facilities?
So as far as the facilities are concerned, for sure, moving towards newer generation of technologies, very strong and standard lab facilities needed. And for developing all those things, huge requirement of the fund. So as of now, we don't have the kind of standard labs which US people, whose Korean peoples have, but still at IIT Patna, we have the kind of lab facilities where we can able to develop these prototypes, and that too by using very less costly equipments, again with very standardization. But in terms of actual components, actual instruments which should be used for this particular purpose, we still lack in that term. And the government have several schemes to fulfill that particular requirement to develop standard labs for different technologies, and we are again heading towards that. But at IIT Patna, we have the kind of primary level technology where we can develop the millimeter wave related structures, the antennas, the kind of RF front ends, the kind of absorber or stealth materials which we develop for defense forces, and all these kind of materials we can develop at our lab here itself at IIT Patna. We do the characterizations here at IIT Patna itself. So at fundamental level, we have the kind of lab facilities available here, and the advanced level of facilities, maybe if government approaches, government supports, for sure we will develop in the coming days.
Wonderful. So I wish you all the very best for those facilities, and I'm very sure you will do that. My next question is very interesting, and in fact a new buzzword. That is about 6G. We have still not explored properly about 5G. Now we have started talking about 6G. So can you please explain what is a 6G wireless communication and how it is different from 5G?
Okay. So as in my previous comments or questions where I said like the Koreans were using this technology 5 years before and we are going towards now this time. So the previous scenario was still a little bit different. The current government, they emphasized more on the technological development going towards Atmanirbhar Bharat. In particular, if I say in the
Yes,
same way,
Dr. Amit,
the
you can
technology
continue.
which we
Yeah.
feel for,
Yes.
uh, uh, the government's approach towards that had changed,
Okay.
and what government emphasized to be in the front of the 6G development. Government have several different schemes, which very recently Department of Telecom under the umbrella of the Prime Minister Office and Department of Telecom, various different ministries, different R&D labs, they came up with the idea to be in the front row of the 6G development.
Okay.
So for that purpose, government announced several technological development, and for that purpose, the government of India and our technologies are also going to be part for that. So
Okay.
as far as users are concerned,
Okay.
what will be 6G as per users? So for users, again, the fundamental requirement is going to remain same, where the user will need, again, user will say for what about, again, if we want higher data rate, because we have the multiple devices. So what to do in that case? That case, again, the technology will have to move to the next level of the frequency. And hence, for that, the requirement goes towards the 6G. At the same time, when we say about the technology moving towards frequency here to there, at the same time, the security is also one major concern. Security towards the data, security towards other things. So, for in terms of all those things, similarly, the algorithm needs to be developed. So, for all these structural requirements, to the fundamental level requirements, to the complete administration level requirements, government is fully prepared for this particular coming 6G technology. So, accordingly, I hope they are going to have lots of different plans to develop that particular.
So, Dr. Amit, there are certain things which are associated with 6G. And to name a few, virtual reality, augmented reality, IoTs, we talk about all those things. So, what impact do you think this 6G is going to have on these kind of domains?
So, the word virtual reality is now, it's not going to be virtual when the 6G will be. So it's completely going to be the real one. Okay. So all is the complete story of, since we will have the huge data available with us that go on the wireless channel in terms of terahertz. So they are not at all going to be the imaginary kind of things. All these things we can make in real-time domain. So 6G is going to again provide enormous changes, which even we may not able to think of as of now. But it is going to provide lots of different changes in terms of, and researchers throughout world, they are having lots of different innovations. Just they started going for that. And we in India also, several groups in India, including our lab, they are also working towards that.
So I was going through your profile and your website. Professor Amit, you are going to organize symposium on 6G mobile wireless communication only. That is in December 2022, this year only, after a couple of months. So we want you to tell us something about this symposium.
Yeah, so as I said, like the government's ambition, the Prime Minister's ambition, the complete India's ambition is to be leader towards the technological development in communication. And hence the agenda of the technologists, the administration, the authorities are to be in the forefront of this 6G technology. And for that purpose only, we are the one who are going to organize 6G Symposium, which is going to be a 2-day get-together for the technologists in the field, the administratives in the field, of 6G. For sure, the communication, that means the Department of Telecom peoples, all the scientists, the researchers, the professors throughout country working in the domain, and the kind of ministries involved with that. So we are going to have a huge gathering for these 2 days, and the agenda is going to be the vision towards 6G, the mission towards 6G, and what will be the roadmap towards this particular 6G development. So it's going to be a very huge event, and through your channel, I would like to invite all the participants, whoever feels interested, please approach our website.
Wonderful. So I'm sure those who will be interested to get the benefit of this, because this is the latest technological domain, Dr. Amit, surely they should join there, and they should be the part of such kind of symposium. I also want Dr. Amit you to tell us something about hands-on training in wave circuit design, characterization, and fabrication that will be done in symposium on 6G communication.
Yeah. So the second part of the symposium lies on circuit designing and development.
Okay.
So again, in the recent trend, you people may also have seen in India we are lacking in terms of IC designs. But whenever we think for technologies means always with circuit. Technologies are not just a kind of simulation. Until unless it is the hardware, then only the technology. So in terms of hardware development, we were lacking. So again, government have different emphasis towards this hardware type of development, chip development, semiconductor circuit-like development. So they have again different agenda on that. So our objective here is also how we can develop the researchers, the coming generations, where we should also have the skill to develop the fundamental circuits, fundamental components. And for that purpose, we have the sessions on this millimeter wave circuit design, not just the design, including the fabrication, including the characterization. That means how you will fabricate those devices in-house, how you will measure those devices in-house, and then after how these devices are going to be useful.
Wonderful.
It's complete.
So I wish you all the very best for this symposium, Dr. Amit, and I'm very sure you are going to do great in this. So Dr. Amit, now we have come to almost an end of this entire session. It was a beautiful session. Now my last question is related to the students, those who want to become part of IIT Patna. So Dr. Amit, we have a lot of centers of excellence, including IIT Patna. IIT Patna is a relatively new IIT, no doubt, with the fresh energy and fresh minds and dynamic academic leadership like people like you. So I want you to tell the viewers, the students who want to become part of IIT system, why they should come to IIT Patna. And specifically this question is towards your department or your field. If a student who must be listening to our entire conversation and whatever you have told, if he wants to become a part of IIT Patna, why he should come there, and what IIT Patna is to provide to such students who are looking for a great career in future.
So thank you for this question. We at IIT Patna, the Meta Antenna Lab, have one of the finest technology in the country towards this millimeter wave technology development. And that's why we always want to play on the forefront of this technological development. And for all this technological development, we need the students, we need the researchers, we need the collaborators, whoever is. So for that purpose, this particular IIT Patna's campus, where we have this millimeter wave technology, that is this Meta Antenna Lab, we are fully equipped with the kind of advanced technologies, advanced devices, and advanced infrastructures as well. So having all these things, we give you one of the best platform to develop your research into to develop your research ethics at the same time. And at the same time, we emphasize more towards product level development, which can be commercialized in the near future. So having all this emphasis, I will simply say those who just even think of having what this 5G, 6G or whatever next is going to be, how it will be the reality one. And if you want to take part of the same, take part for the same change, welcome all of you for IIT Patna in my lab, Meta Antenna lab. We'll be for sure happy to be with you at any point of time.
Okay, that's wonderful, Dr. Amit. Now, my last question for our interaction, and that is related to your prospective students. Dr. Amit, students obviously want to learn a lot from mentors like you. They know your profiles, they go through the website, they see what work you've done, and they want to work under your mentorship and guidance. But the question is, what do you see in your prospective students who want to join under your guidance for masters and doctorate?
So there is only one thing which students should have, and in my opinion everyone have, but only the thing is they have to explore that part of them. That part which I always look for is the idea for doing the change. We don't want anything else. The change in terms of technology, we say the idea of doing the innovations.
Okay.
If your mind is capable to generate the idea, that means you can do all the possible things. And that is the only thing which our lab looks for. And since we are specialized towards the innovations, towards the next generation of the communication, in particular to the millimeter waves and the terahertz waves in the coming scenario. So if you think that you can have the kind of innovations, if you can do the kind of changes in technology, and for sure for the society, for the humanity, for the country, then there is nothing which we expect other than this kind of things. And if you have this kind of things, most welcome.
Okay, that's wonderful. So, Dr. Amit, I must say that this was a wonderful marathon interaction session with you. So, I had almost 20 interaction points for you, and you have provided the answer to each of these questions very simplified manner and in a very straight manner. And I'm very sure those students who will listen to it, they will surely get a lot of idea, and they've learned many things in the interaction today about 5G, 6G, and different 5G communication domains, millimeter waves. So many other things they've learned, and I'm very sure that will help them a lot. So I wish you all the very best for your future academic career, and thanks a lot for your time once again.
So from my side also, thank you all of you, and thank you to the viewers of this channel, and thank you, Dr. Vijay.
Thank you.